So in this video, we want to answer the question, what is the derivative of a linear function? And remember, when we ask this, we're asking what is the slope of the tangent line for any point on the line, or what is the instantaneous rate of change for any point on the linear function. Okay, so let's draw a linear function for us to look at. It can be any linear function, any line. I'll just draw one here, and let's call it f. Then we are wanting to know the derivative for any point, so let's just pick an arbitrary point. It has an input, an x value, and an output, an f of x value. So if we think of a tangent line at this point, the tangent line is actually going to follow that linear function we've already drawn exactly. So the slope at x is actually just the slope of the line. So more formally, this means that at any point x f of x, the tangent line is the function itself. So the tangent line is just that line. So if the derivative is just the slope of the tangent line, and the tangent line is the linear function we've drawn, they're the same thing, the derivative is just the slope of the line. So the derivative of a linear function is just the slope of the line it represents. So again, the derivative in general is the instantaneous rate of change at any point. And if we think about any point on this line, all of those points have the same slope. They have the same instantaneous rate of change. So the derivative, the slope at any point, is just the slope of the line. So conceptually, this is what the derivative is, but we also want to think about this symbolically. So if we have an equation of a line, f of x equals mx plus b, the derivative, f prime of x, is m. So the derivative is the slope of the line. So we've talked through a conceptual argument, but I want to use the limit definition of the derivative to prove this more formally to you. So again, we are asking, what is the derivative of a linear function? That's f of x equals mx plus b. Linear functions can be written other ways, but this is sort of this most simple standard version of it. Remember, the derivative is the instantaneous rate of change, it's the slope. And so from what we've talked through, we think that the derivative of f of x should be m. So the derivative of a linear function should be m. We're going to check this using the limit definition of the derivative. So in general, the limit definition of the derivative is that f prime of x, that's our derivative, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. That's our difference quotient. That's the slope of the secant lines. As h gets really small, they approach the tangent line. Alright, so for us, f of x is mx plus b, so if we replace x with x plus h, we get m times x plus h, all plus b. And then we subtract off f of x, and this is all divided by h. Remember that with our limit, our intention is to figure out what's happening to this difference quotient as h approaches 0. And the way we want to figure this out is to do some simplifying first so that we can understand the limit, so we can evaluate it. So to simplify, I'm going to distribute through these parentheses. So I still have my limit, and then in the numerator, I'm going to have m times x plus m times h plus b. And then we'll subtract off mx and then minus b, and that's still divided by h. Alright, so I'm seeing some things that will cancel. We have two mx's and we have two b's, and so I'm going to cancel those out. Specifically, we have a plus mx and then a minus mx, and we have a plus b and a minus b, so those are going to cancel. Then rewriting this, we still have our limit, and we're left with just mh divided by h. Those h's can cancel out, so I just have the limit as h approaches 0 of m. And since this doesn't have any h's to send to 0 left, we've gotten rid of all of them, the limit is just m, so the limit is just the slope of the line. So this is our formal proof that the derivative of a linear function mx plus b is just m, the slope of the line. As a final way to solidify what's going on here, let's do an example with an actual equation of a linear function. So let's say we have a function k of x equals negative 2/7 x plus 12. This is a linear function. It's written in slope-intercept form, mx plus b. The task I'm going to ask you to do is to find k prime of x. So find the derivative of k. So take a second, pause, think about what you have learned and what you think this is. What is the derivative of k? So remember, the derivative is the slope, it's the m value, so the slope of k of x is negative 2/7, so k prime of x equals negative 2/7. To go through this one more time, the derivative is the slope at any point on the function. Our slope is constant, it's always negative 2/7, so the derivative is negative 2/7. This process will work for any linear function, so the derivative of a linear function is always just the slope of the linear function or the slope of the line. Okay, so that's it for this video. Thanks for watching, and I will talk to you in the next one.